Today we will discuss about the B plus tree. So what is meant by the B plus tree here? So it is also part of the file organization and the file indexes. File indexes. So we will discuss what is B plus tree and what is the purpose of the B plus tree. The B plus tree is a balanced binary search tree. It is a balanced binary search tree. See, search tree. Using this, you can store the data. You can search the data in the tree format. It is a one type of binary search tree. Binary means two here. Two here. It is a one type of tree. You can store the data in the form of tree. See, in the tree, we have the root nodes. After that, stems, leaves, like that we have a some structure for a tree. Here also we can store the data using some root nodes and the leaf nodes. The actual data contains at the leaf nodes. Leaf nodes. So that is the B plus tree. It is a balanced binary search tree, means it follows a multi-level index format. Already we discussed yesterday index. So it follows the multi-level index format. In the B plus tree, leaf nodes denote the actual data point, as I said. So actual data contains at the level of leaf nodes. B plus tree ensures that all leaf nodes remain the same height. Same height means, suppose there is a root node. Right. After that, leaf nodes, in that leaf node, binary means two not. So again, only two leaf nodes. Again, if you want to contain the leaf nodes, sub leaf node, suppose the first leaf node contains the three values and second leaf sub leaf also contains the three values, like that. In the B plus tree, the leaf nodes are linked using the linked list. So I think you learned about the linked list in the data structures. So in leaf nodes are linked using the linked list. So using linked list, you can maintain the link between the leaf nodes in the B plus tree. So then it will follow the random access as well as sequential access. If you want to access the values from the B plus tree, you can access randomly as well as sequence. Now we will see the structure of the B plus tree. This is the structure of the B plus tree. In the B plus tree, every leaf node is a equal distance or equal length from the root node. The B plus tree is the of the order n and n fixed of for every B plus tree. See here, D and G are the root nodes, and A, B, D, E, F, G, H are the GHS are the leaf nodes. See, each leaf node contains the same length, means ABC. Here we have the only three. Here also DEF. Here three. Again GH, some empty, three only. So like this. So leaf node also known as the, root node also known as the internal node. At most, an internal node of the tree contains the n pointer. See, this is the root node. N pointer means it may be 2, 3, 4, 5, 6, 7, 8. Based upon your requirement, it will decide. Next one is the leaf node. The leaf node of the B plus tree can contain at least n by 2 records, pointers, and n by 2 key values. So if there is a n values and it contains a n by 2, 10 means 10 by 2, 5 values. How it can store the values? First we will decide. So we have these numbers. How many numbers are there? 5 to and sorry, 1 to 100 numbers. Suppose 1 to 100 numbers if you want to store in the B plus tree, then you can decide how many root nodes. They decided the 25, 50, 75, 3. Each one have the 4. 4. See, 25 is the root node and 50 is the root node and 75 is the root node. These are the root nodes. Then you have to store the remaining values in the B plus. How it will store in the B plus 3 we will discuss. Suppose if you want to store the 5 value in the B plus 3. So first it will compare with the 25. If it is less than the 25, it will store the here C in the left side. In the left side 5. Again 10. Again it will compare with the 25 value. So 10 is also less than the 25. It will store the 10. Again 15. 15 will compare with the 25. 15 is less than to the 25. Then it will store the left side of the 25. Next value is the 20. Again it will compare with the 25. Then is less than 25. It will store the left side of the 25. Next 25. It is equal to 25. Then that time also it will store in the right term. If it is equal or greater than, then that time it will store that value from the right side of the that one. So next one is the 30. 30 also greater than 25. Then it will store the right side. 35 also greater than 25. Then it will store the 30 right side of the 25. Next 40 also greater than 25. It will store the next one is the 50. First it will compares with the 25. It is the greater than 25. Then actually it has to store in the right side, but it is already filled. There is no space. There is no space. That's why it came to here and it stored in the right side of the 50. And like that 55, 65, 70, next 75, 80, 90, 95 also. Like this, you can insert the values in the B plus 3. See, 25 is a root node and this is the leaf node. So what is the strength of this one? 1, 2, 3, 4. Remaining leaf nodes also same strength 4. See, here also 1, 2, 3, 4. Here also 1, 2, 3, 4. 1, 2, 3, 4. That's why it is called a balanced binary search tree. That's why it is called a balanced binary search tree. So, till now we discussed about the what is the definition for B plus tree, what is the purpose of the B plus tree, so what is the structure of the B plus tree, how we can store the values in the B plus tree. Itself it is saying binary search tree. Search means we can search, means you can access values. You store so many values here. Suppose if you want to access number 55, then you have to search for 55 in the binary tree. See how you can access the 55. No?
Earphones.
Alafi, please mute yourself. Suppose you have to search 55 value in the below structure. First, we will search for the intermediary node. Intermediary means root node. Root node. First, we have to search for the root node. So, node which will direct to the leaf node that can contain the record of 55. So, if there is, what are the root node? 25, 50. Then directly you can go to the right side of the 50 for the 55. If you are unable to find out the root node, then you have to check all these things. With 5, you have to set here 5, 10, 15, 20, 25, 30, 35, 50. Then it will take the lots of time. If you find the internal node or root node, then it is easy. So 55 means it is the bigger than 50. Then automatically you can move to the right side of the 50. Then you can find the easily. So like this, you can search the values in the B plus tree. In the internal node, you will find the branch between the 50 and 75. Suppose if you are unable to find you can find the 75. So 75, 55 is the less than the 75. Then you can search from the left side of the 75. Then only you can easily identify the 55. Like this, you can insert the values, you can search the values in the B plus tree. Next, already you inserted some values in this tree, B plus tree. You have the 3 internal nodes or root nodes, and each root node contains the one leaf. That is the strength of the 4. So this is the balanced tree. There is no space to insert the another value. But I want to insert one more value. What should I do? How can I insert? There is no space. It is filled. This leaf node also filled. This leaf node also filled. How can I insert one more value? It is balanced, na? Already balanced tree. So now we will discuss how we can insert one more value. So that one only I mentioned here. B plus tree insertion. Suppose we want to insert a record 60 in the below structure or above structure of the B plus tree. It will go to the third leaf node. What is the third leaf node here? 60. Here. This is the first leaf node. This is the second leaf node. This is the third leaf node. Why? Because after 55, below 60, before 65, 60 has to come. That's why it will go to the third leaf node in the structure. Okay? It is balanced tree already. And leaf node of this tree is already full. So here it is leaf node full, here this leaf node full, this leaf node full, and this leaf node also full. So we cannot insert the 60 there. But it is mandatory. I want to insert 60. The user requirement has to insert the 60. What will you do? What should you do? What is the solution for that? In this case, we have to split the leaf node. Then we have to split this leaf node into again 2 parts. First part has to contain the 4, and the second part has to contain the 4 or 2, 3, 4, like as per your requirement. See, in this case, so that it can be inserted into tree without affecting the fill factor, balance, and order. See, we will discuss here. The third leaf node has values. What are the values? 50, 55, 65, 70. And its current root node is the 50. We will split the leaf node of the tree in the middle. In the middle means this. So how many we have? 1, 3, 4. So 2 one side, another 2, another side, middle. So that it is not altered. If you divide it like that, it balance not altered. So we can group 50 and 55, 60, 60, 70 into leaf node. And we have one more here. That is the value 60. So if these two has to be leaf nodes in the intermediate means root node, cannot branch from the 50. See, whatever I said, have to add. It should be have 60 added to it. So if you want to add here, you have to divide this leaf node into the two parts, and again you have to add more root node to the one more node to the root node. Here we have the only three. You have to add one more here, 60. That is the fourth one. Then you can easily balance your B plus 3. See, again it is the four nodes. So 50 greater than 50 equal to 50 right side. 55 greater than 50, so right side. So 60 again. This is equal to 60. That's why it is come to the right side. 65, 70. So if you want to store the 56, 57, it will come here. Okay. If you want to store the 71, 70, it will come here. Like that, you can insert the values in the B plus 3. So this is now balanced B plus 3. So if you want to insert so many values again here, you can add the one more root node here, and you can split the leaf node into the two parts. So like this, you can insert the values in the B plus 3. Now we will discuss how to delete the B plus 3, a particular value. Yes, see here, suppose if you want to delete the 60 from the above example, in this case, you have to remove the 60 from the first. You have to remove the root node. After that, you can remove the leaf node. Leaf node. It is not possible to directly. Suppose first you have to First you have to delete the leaf node. After that, you have to remove the root node. Directly, it is not possible to delete the root node. Suppose if you want to cut the one tree, first you have to cut the branches. Branches. After that, you can remove that from the root node onwards. Roots onwards. So like that here also, if you want to delete the one value from the B plus 3, first you can find out the root node. So based upon that, you can move to that value and you can remove from the leaf node. So if that leaf node is empty, then you can delete the root node also. This is the logic behind the deletion of B plus 3. This is the information about the B plus 3. So what is the definition for B plus 3? What is the purpose of the B plus 3? So what is the structure of the B plus 3? In B plus 3, we have the leaf nodes or internal nodes and root nodes or internal leaf nodes. It is a balanced tree, and you can set the record for the in B plus 3, and you can insert how to insert the values in B plus 3, and how to insert the more values in the B plus 3, and how you can delete the B plus 3 values. Yes, this is very, very important. You have to concentrate on this. Even in UGC net also, they are asking some questions on the B plus 3. B plus 3. If you want to qualify in the UGC net, then you have to concentrate on the B plus 3 also. They are asking questions on the B plus 3 also. This is the file organization. Regarding file organization, what is file organization? What are the types of file organization? What is indexing? What are the types of indexing methods? And what is B plus 3? We discussed. And we discussed in yesterday SQL commands also. SQL commands also. I think so. Whatever I'm explaining, it is not sequential in your book. Sequential in your book. So B plus 3 is somewhere Wait for a minute. Are you able to see my screen?
Yes, sir.
Okay. So now we will discuss the storage. What is the meaning of the storage here? One minute. So we will discuss about the storage. What are the storage devices? So in our houses, if you want to keep the clothes, what will you do? If you want to keep the books, we have the some shelves or some almaris are there in our home. You can keep all those things in the shelves or almaris. Like that, in computer, if you want to store the data, we need the memory. We need the memory. To store the data in the computer, we need the memory. Memory. So, what are the memory devices are there in the computer? Now we will discuss. That is the storage. Storage means we are storing the data in the memory. Again, in this we have the two types: main memory and the primary memory, secondary memory. So, secondary memory means we consider secondary memory considering the some devices are the secondary memory devices. Am I audible? Just give me response. Am I audible or not?
Yes, sir.
Okay. So these are the some we have the some primary storage devices are there. Some secondary storage devices are there. Primary storage devices are the RAM, ROM, like this. With these are called the primary. Secondary means hard disk, CD, DVD. Some things are there. Those are called the secondary. So primary memory also called the main memory. Main memory. So what is meant by the main memory? So it allows general purpose machine instructions to operate on main memory, and at the same time data is lost on power failure. Sometimes even system gets crashed. It is also stores entire database with the high cost and too small, basically in megabytes. Next one is the cache memory. So what is meant by the cache memory? It will sit in between the user and the main memory. Cache memory sits in between the user and the main memory. So already we have the primary memory, secondary memory. Why we need the cache memory? Why we need the cache memory? I think already you learned all these things in the fundamentals of information technology in first sem.
Yes, sir.
Am I correct or not?
Yes,
Then
sir, you are correct.
Then why we need the cache memory? Why we need the cache memory or cache memory? So it is faster than the main memory also. Main memory also. Why? Why it is faster than main memory? Why it is fast? Cache memory is why it is faster than main memory? Listen. Cache memory means it is a buffer. It is a buffer. So see here, it will store the recent files. Whatever you see in the recent files, folders, whatever you use the recent files and folders, it will show. It will save. Maximum 10 folders, maximum 10, 20 files, it will save. It will save. Suppose you use the 10 folders, 20 files today. Today, you shut down your system. You shut down your system and tomorrow you open your system. Suppose if you want to open the same 10 folders, 20 records, then no need to go to that main memory. Simply you can access from this cache memory. Then so that's why it is a very fast compared to the main memory. It is a one type of buffer. It will store the recently used files and folders. You can access, no need to go to the again main memory. If you want to use again and again same folder, you can access that folder from the cache memory. No need to go to the main folder. That is the purpose of the cache memory. Next one is the flash memory. So this is equal to the EEPROM, electrical erasable programmable read-only memory. So it is also known as flash memory, also known as the EEPROM. So EEPROM is the one type of the ROM, read-only memory. So in this memory, you can, if you write once, if you want to, what is this? Erase the data, then what will you do? Using some, in this, see here, in this type of memory, data is not lost upon power failure. So in ROM, once you write the data, if power failures or any damage occurs, data will not last. It takes approximately 10 nanoseconds to read the data, 4 to 10 microseconds to write once. So EEPROM takes that only 10 nanoseconds to read the data from, and 4 to 10 microseconds to write the data on the ROM. So writing the data is more complicated in the flash memory. So once it is successful, it is very useful. Next one is the magnetic disk storage. See, these are the memory storage devices. Cache, main memory, flash memory, magnetic disk, optical disk, and the magnetic tape. See, we will discuss about the magnetic disk storage. So it is a long-term storage where entire database is stored on a disk. Data is read and wrote to main memory from the disk and vice versa. To store the data for long time and to make any changes to the data, it must be stored on a disk. Disk storage is direct access storage so that the data can be read in any sequential access. So magnetic disk is a one type of storage device. So in this also you can store some memory, magnetic disk. So directly to the disk and vice versa, main memory. Directly you can save the disk to main memory to the disk. So you can use this one in the long time. So that is the magnetic disk storage. So next one is the optical storage. What are the optical storage devices? CD-ROM, DVD, pen drive, and the floppy disk. These are all come under the optical storage devices. So using this also, you can store the data on this. So what is the difference between CD, DVD? There is a little bit difference. Compared to the floppy, CD can store the high amount of data. Compared to CD, DVD will store the high amount of data. Compared to the DVD, pen drive store the high amount of data. Like this, we have the little bit difference between these. Tape storage means it is used to primarily to archive the data and backup as it reads data sequentially. It is slow at access and cheap. It is utilized in the protection for the failure of disks. So tape storage means in olden days they used the tape records to listen the songs or any audios. So that in that tape they store the data. So you can access the data sequentially. It is not possible to access the randomly. The next one is the magnetic disk and the magnetic tape. Whatever we discuss now, tape is tape storage means that is called a magnetic disk. Already we discussed. So this is the hard disk structure. In your system, you have hard disk na. So this is the structure of the hard disk. Hard disk. So first data will store in the tracks. Sorry. So this is called the spindle. This spindle will rotate. This is called the arm, and there is a head, read and write. So in every arm have the read and write head. Every arm have the read and write head. So using this, you can write and read the data from the hard disk. So entire this is called the plotter. Entire this is called the plotter. See here, this all plotters are called the cylinder. See, this is the shape of the cylinder. So this is the track, and this single box is called the sector. Entire single these boxes are called the track. So this is the structure of the magnetic tape. Just now we discussed it. Two wheels are there. In between two wheels, there is a tape. On the tape, we have the two heads, read and write. We can write the data on the tape. We can read the data on the tape. Then we can forward the data from one wheel to another wheel. So this is the definition or information regarding this structure of the magnetic tape storage device. See, optical storage devices, already I said now, CDs, DVDs, pen drives, and HDDs, all are come under the optical storage. In this type of storage, data is read and written with a laser. Usually, data is written to optical device like compact disc and DVD like this. Already I explained. These are some sample pictures from CD, DVD, Blu-ray. These are all common as flash memory. So pen drive, this is the pen drive. This is also one type of pen drive. So what are these things? What about these things? This is the storage. This is also storage device. We can use the storage device on our mobiles, memory card. These are also memory cards. We can use these in the cameras. We can use these parts in the cameras. So these are all common the flash storage devices. Pen drives, these memory cards. Next one is the tertiary storage. What is meant by this one? So using this, you can store the huge volumes of data. Since such storage devices are external to the computer systems, it will not come by default in the system. You have to add these systems externally. They are the slowest in speed. Why? Because we are storing the huge amount of data. That's why these are the slow. These storage devices are mostly used in backup of the entire system. Suppose I stored the data in my system from since last 7 years. So if I want to store that large amount of data, then I can use this type of storage devices. So this is the picture for the territory storage devices. So primary storage, secondary storage, and tertiary storage. Removable storage media. Pyramid shape. Next one is the RAID storage. So redundant arrays of independent disks. RAID stands for refers to the redundancy array of the independent disks. It is a technology. It is a one type of technology which is used to connect multiple secondary storage devices for increased performance. So already we discussed the some secondary storage devices. So we are grouping those secondary storage devices into the one group to increase the performance, to avoid the data redundancy. So in this we have the 7 levels. RAID 0 level, RAID 1 level, 2 level, 3 level, 4 level, 5th level, 6th level, 7th level. So functionality is to store the data only. But there is a little bit some differences are there. So we will discuss. First one is the we have to avoid the redundancy means duplication of the data. The first RAID 0 level. So it provides the data stripping. That means the data can place across multiple disks. Multiple disks. Suppose if you are grouping the 3 disks into a one group, then your data can place on a 3 disks. It is based on stripping. That means if one disk fails, then all data is lost. Suppose one disk is failed, then you lost your data. Then you can take from the another disk. So it will improve the performance of the what is see, these are the some three disk 0, disk 1, disk 2, disk 2. So if you are storing the see 20, 24, 28, 32, 21, 25, 29, 33. Again here 34, 26, 22 like this. So these are the some advantages of RAID 0 level and some disadvantages of the RAID 0 level. Next one is the RAID 1 level. So this level is called the mirroring of data. What is meant by the mirroring of data means you are copying the entire data from one drive to another drive. So it provides the 100% redundancy in case of a failure. So in case of any disk failure, you can copy the redundancy means copy data, copy duplication data. So if you are copying the entire data into the one drive to entire data means you. So here disk one is the one data and disk two also has the same data. That is the duplication of data. Redundancy means duplication of 100% it will provide. So whatever you lost the data, exactly that type of data available on the another drive. That is the purpose of the RAID 1. So some advantages and disadvantages, this one also. Next, RAID 2. So it consists of the bit level stripping using Hamming code parity. In this level, each data bit in a word is recorded on a separate disk. So in this level, each data bit in the word, suppose there is a word that is the due. For that, this due will store in the memory in the bit level, one bit level. So that bit level is recorded in the separate disk. So these are the some advantages and disadvantages. Next one is the RAID 3 level, consists of the byte level, that is the bit level, this is the byte level. So it is compared to the better than the RAID 2. So this is the high speed data transmission is possible in this level compared to the RAID 2. So these are the some advantages and disadvantages of the RAID 3 level. Next, fourth level. So in this, we are splitting the data in the block level. In second level, we are splitting the data in the bit level. Third, byte level. Next, we are splitting the block level. For the performance increase, we are doing all these things. Next one, the fifth level. So it is a slight modification of the RAID 4 system. The only difference is that in RAID 5, the parity rotates among the drives. So this parity means already in the hard disk we saw the one drum that is rotating the like this here also the parity will rotate among the drives. These are the some advantages and disadvantages of RAID 5. Next one is the RAID 6. This is an extension of the or advanced concept of the RAID 5. This is in this also it contains block level stripping with two parity bits. In RAID 5 we do stripping the only one parity bit. Here we are stripping the with the two parity bits. Next one is the database system architectures and the data models. See, already we discussed the database management architecture in the previous class. This is the architecture of the distributed database management system. Distributed database management system or centralized database management system. See, centralized database management system. In centralized database management system, data will store in the only at one place. So any client wants to access from that place only. Suppose if you are sitting in America, you can access from the India only. If you are sitting in the Dubai, you have to access from the India only. Why? Because the database centralized in the India. These are the some advantages and disadvantages of the some advantages of centralized database. Already we discussed in the centralized database system in the previous class. Again, they mentioned here some advantages and the disadvantages. Next, we will discuss about the client server architecture. What is meant by the client? What is meant by the server? What is meant by the server? 1 minute, please wait. Client server. Who are using the system? So now I'm using my laptop. I am the client. You are using your system, your laptops or mobiles. You are the clients. Who are the server? The Zoom. So who is the mediator between you and me? The Zoom. Zoom is the server using Using Zoom server, we are communicating with each other. Using Zoom server, we are communicating with each other. This is called the client server architecture. Using server, we are communicating with each other. We are sending the request to the server and we are receiving the response. The client will send the request to the server and server will give the response to the client. That is the client server architecture. You are also one client. I am also one client. Who is the server? This Zoom technology is the server. Server. So for Zoom server, we are requesting. So we are giving the some code, all these things. Please connect to the this meeting. You are requesting, I am requesting. Then it is giving the response. It is connecting you and me. Here I am giving the teaching to you. You are listening. So that is the client server purpose. So again we have the types. Some computer models are there. So one tier architecture, two tier architecture, and multi-tier architecture or three-tier architecture. Multi-tier architecture. First, we will discuss about the one-tier architecture. So, what is meant by the one-tier architecture means the system, only one system itself acting as a client and server. Client and server. Suppose I am using my laptop. So, my laptop is the client. At a time, it is working as a server. So, how is it possible? Suppose say I want to store my details. What are those details? My education details. So in which year I completed the first class, in which year I completed the second class, in which year, so up to my PhD level. That is the I can store those details in the Word or in the Excel. Excel here means in my system. Excel database. Database means database also in my system, and I'm using my database. So my laptop working as a client as well as server, That is called the one-tier architecture. One-tier architecture means the DBMS software and the client both are the same. Sorry for the disturbance. So here one-tier architecture means the client as well as server is the only one system. That is the one-tier architecture. See, DBMS software database, single-tier client server computing model. Next one is the two-tier architecture. So what is meant by the two-tier architecture? So this is the client, somewhere else is the database server. Database server. See, using my laptop, I am buying some in the Amazon. In the Amazon. Amazon website is the server. My system is the client. My system is the client. So Amazon server is not included in my system. That is somewhere else. I don't know where is it. But using internet, I am communicating with the Amazon server. I am buying some things. So my laptop is the client. I'm the client. So Amazon system is the server. Amazon system is the server. This is called the two-tier architecture. This is called the two-tier architecture. One-tier architecture and the two-tier architecture. Now we will discuss about the three-tier architecture. So what is meant by the three-tier architecture? In this we have the three levels are there. In this we have the three levels are there. See, clients are somewhere else and the databases are also somewhere else. So if you know the Amazon website, simply you can tell www.amazon.com, then you can connect to the Amazon server. So that is a suppose you don't know the you didn't know the Amazon website URL or Flipkart URL, some other sites URL. Then what will you do? Then you can type those things on the Google. Then Google will communicate with that server and it will give the response to you. Means here third person is involving. Who is the third person? Google. Google is the third person. Your system is the client, and Amazon server. Amazon system is the server. Amazon system is the server. This is called the three-tier architecture. If you don't know the particular server URL, then you can search that in the Google. Means you are asking the third person. You are not directly communicating with that server. The Google will communicate with the server and it will give the response to you. So that third person Google is the three level. First level is the client. Second level is the that Google. Third level is the server. So it's a server. That's why it is called the three-tier architecture. Three-tier architecture. So again, a multi-tier architecture or n-tier architecture. So what is the meaning of this? See here, three-tier means suppose if you search it in Google, so many links are available. So many third parties are giving the information to you. Those third parties are called a multi-tier architecture. So many clients are searching. So many websites are available. So many servers are connected. That's why it is called a multi-tier architecture or n-tier architecture. So this is the client server architecture. So what is meant by the client server architecture? The client is sending the request to the server, then server gives the response to the client. Again, these are the some types. One tier architecture, two tier architecture, three tier architecture, and multi tier architecture or n-tier architecture. Not n-tier. N stands for the node. So in one-tier architecture, one system can act client as well as server. And two-tier architecture, client is separate and the database server is separate. And three-tier architecture, using Google, you are communicating with the so and so. This is the client server architecture. So we have 5 minutes more. If I started the new topic, so it is not possible to complete within the 5 minutes. I am sorry to say this. So if you have any doubts, please ask me now. Till now, from starting onwards till now, do you have any doubts? Please ask me. Today is, I think, last class. So I will explain those doubts clearly. Yeah, definitely. I will give the important questions also. Please add my number in your group. Then I will post the important questions in your group. So many members are giving personally keeping the messages. Sir, please send me this one. Sir, please send that one. This one like this. It is not possible to send each and every person. Please add my number in your group. Then I will post all the things in your group. Then you can read it anytime. You can access anytime. So I'm typing in my number here. Please add. Important questions, whatever I explained in previous material. So this is the your book. So any doubts, please ask
Sir,
me.
can you explain the architecture of DBMS, sir?
Architecture of DBMS.
Yeah,
Okay.
DBMS.
The three levels: internal level, conceptual level, and external level. Okay. This is also called the physical level. Physical level means that level is communicating with the hardware. Okay. And in conceptual level, it will describe the entire your database. So what is the database type of database? Is it what are the tables are there? What are the data types used? How many columns are there? How many rows are there? That is the conceptual level. Remaining level is the users. How many users? Application level. So using some application, either SQL or Oracle, whatever you are using the application, you are using. Okay. So that is the structure of the DBMS, database management system. Clear?
Yeah, okay, sir.
Yes, 3 minutes more. Any doubts? So I gave my number here. If you want any doubts, please post me in the WhatsApp group. Then I will give you the explanation also. Okay, thank you very much.
Thank you, sir.
Thank you.